Thanks for the introduction. As Colin said, I'm going to be talking about shrinking in the age of Kotlin. First, let me introduce myself. So my name's James. I'm a software engineer at Guard Square, and I work on ProGuard, DexGuard, AppSweep. So basically working with mobile security related things, working with Java bytecode, working with Delphic bytecode, code analysis, obfuscation, and all of these related things. Before that, I did something very different. I worked for a few years at CERN on control systems, and before that, I did a PhD in code analysis and metrics. As the title said, I'm going to be talking about shrinking, but what is shrinking? What do we mean when we say shrinking? And so assuming that a lot of people listening are going to be Android developers, you'll probably have an APK. If you're a Java developer, you have maybe a jar. And then at a high level, when we talk about shrinking, we want to make these smaller. And then there are well-known shrinkers, for example, like ProGuard, R8 in the Android world. There are others, for example, Redux, YGuard. And all of these aim to make your app, whether it's an Android app or a Java app, to make them smaller. But let me first set some expectations. My talk here is not a shrinker tutorial, so I'm not going to show you how to fix your keep rules. I'm not going to show you how to use ProGuard, and it's also not a sales pitch for a specific shrinker. So, as I said, I work for Guard Square and I work on ProGuard and DexGuard, but it's not a sales pitch for ProGuard. Everything that I show you here is quite relevant for any shrinker that wants to work with Kotlin code. So if it's not a sales pitch and it's not a shrinking tutorial, then what am I going to be talking about? Well, there are three questions that I want to answer. The first one is, how does a shrinker process Kotlin generated code? What's the difference between Java classes and Kotlin classes? And how you can build tools to analyze and modify Kotlin classes. So first, let's talk a little bit about how a shrinker works. When we talk about shrinking, we're typically talking about three different things: tree shaking, code optimization, and name obfuscation. So for tree shaking, it's all related with the parts of your app, which are classes, methods, fields. Imagine if you connect all together the use parts of your app. So all of the methods that call each other, you make a branch in your tree if it's used. So if one method calls another method, you add a branch in your tree, and then you shake your tree, and all of the unconnected pieces fall away. And so this is really useful, for example, when you're using libraries. If you want to use one or two features from a library and the rest of the library is not really useful to you, if you add a dependency on that library, you're going to pull in the whole library. So if you just want to use part of the library, then a shrinker can help you make your app smaller. Then the second kind of shrinking is code optimization. And this is all about rewriting the code itself to reduce size and sometimes also to increase performance. So for example, if we have some code like this and the shrinker can tell that one branch is never taken, then it can rewrite the code to something shorter. And the third type of shrinking is name obfuscation. So this one is all about reducing the size by using shorter names. So for example, if you're a Java enterprise developer, you might come up with some name like service definition, configuration, being printer, setter, task wrapper. But more characters means more bytes, means a bigger app. So if we can rename it to something shorter, we can save space. Just a short aside, this is not the main topic of the talk, but name obfuscation that's done by ProGuard or R8 is not alone a security solution. So it might make it a bit harder to understand if you rename everything, but it's not a real protection. But that's not the main topic of this talk. I want to talk to you about Kotlin and shrinking. So the talk, title of the talk is Shrinking in the Age of Kotlin. So why in the age of Kotlin? What's different now? Isn't it all just Java bytecode? So the Java compiler compiles to Java class files, the Kotlin compiler compiles to Java class files as well. So what's the difference? Why does the shrinker need to know about Kotlin? What problems does that cause for shrinkers? So let's take a look at a really basic example. So this is like hello world in Java, in Kotlin. So if we compile one with the Java compiler, we compile one with the Kotlin compiler, and we use Java P to print the disassembled bytecode. Then it looks like this. So the actual content is not important here, but as you can see, I printed with the same font size. You can see the one on the right is much longer, and that's the Kotlin one. And they're both just hello world programs. So I can highlight a few parts of the file here. So there's a header, which is very similar size. The constant pool, you can see already that the constant pool for the Kotlin version is bigger. Something that doesn't appear in the Kotlin version here is actually a constructor. That's because from the Kotlin point of view, we didn't create a class. So the Java class that's generated, we know is not going to be instantiated. And then there is the main method. And actually in the Kotlin version, there are two main methods because our main method didn't have any parameters, but the entry point for Java programs has a string args array. So in that case, then one delegates to the other one. And then for this talk, the most interesting part is the Kotlin metadata. We'll come back to what the Kotlin metadata is later, but why do we need metadata? Why do we need some extra information about Kotlin that cannot be represented in the Java class file? So let's look at a simple example. If we have a data class in Kotlin, well, when you compile it to Java, to the Java platform, to a Java class file, you get a class because Java doesn't know anything about data classes. Another example, if we take one of the newer features of Kotlin, the context receivers, if you compile this to a Java class file, you get something that looks a bit like this. So basically, the context receivers get added as extra parameters to the method. But there is nothing to indicate here that the parameters are context receivers compared to normal parameters. And then Java doesn't have the concept of the nullable types. So when you compile a string and a nullable string, they both end up as string in the Java class file. And with type aliases, Java doesn't have any concept of aliases. So when you compile a type alias, all of the references will be the underlying type, for example, with the string here. And there's much, much more. And the important thing is that missing or invalid metadata is a problem for code that inspects Kotlin code. So for example, if you use reflection, then the Kotlin compiler needs to understand all of the Kotlin features of the code. Or if you're writing a library and the user of your library needs to be able to compile their code against the Kotlin features in your library. or for IDE inspections, so you can get nice auto-completion, for example. Okay, so that's why we need metadata, but how is it encoded in the Java class file? So let's go back to this picture here, and right at the bottom there is the Kotlin metadata. And this is what it looks like if we zoom in a bit. So basically, it's just a runtime annotation, a runtime visible annotation, sorry. And I put just in quotes because actually most of the important information there is encoded in binary data in one of the fields. But since it's a runtime visible annotation, actually, and Kotlin is open source, we can actually look at the definition. So this is what the source code for the metadata annotation looks like. You notice that there are a bunch of different fields. So the first one is the kind. Is it a class? Is it a file? Is it a synthetic class? Is it a facade? The next fields are version numbers. And then here is where in the D1 field, this is where the metadata is encoded in binary formats. The next field has strings which are referenced by metadata. And then there are some extra fields for some other things. Okay, so that's what the metadata is, why, and when we mentioned why we need it. But then why is this important for shrinking? So the talk is about shrinking in the age of Kotlin metadata, in the age of Kotlin. Why is it important that your shrinker knows about the metadata? Let's take one of the most basic examples. So as we already said, that the Kotlin metadata is actually just inside a normal Java annotation. So if you run the shrinker on your app, then typically the metadata annotation itself is not referenced. So if your app doesn't know about Kotlin, or you do not configure your shrinker to specifically keep the metadata annotation, it might just be removed. And then if we think about renaming, or if you rename the Java methods in your class, the metadata still refers to the old methods unless your shrinker knows about the metadata and knows how to update it. And then finally, to shrinking methods, for example, if you remove a method from your Java class, your shrinker needs to know to update the Kotlin metadata because this also refers to that method. So let's talk a bit about how ProGuard processes Kotlin metadata. So basically, ProGuard has a model of the metadata and of the Java class file, and it links together different components. So for example, the class metadata is linked to the Java class. The function metadata is linked to the Java methods. And there are two basic rules here. If the Java part is renamed, rename the Kotlin part. And if the Java part is unused, remove the Kotlin part. Okay, so that's basically how ProGuard works at a very high level when we're talking about Kotlin metadata. But let's go a bit deeper. So how do we actually read and modify the Kotlin metadata? And to do this, I'm going to be talking a bit about ProGuard Core. So this is a project that was born out of the ProGuard project. So this is actually a library that allows you to read and write class and jar files. And it's the core library that's used by ProGuard. So you can modify, generate, and analyze code, and you can inspect and modify metadata. And this functionality is actually powered by a library written by JetBrains. So I want to show you a small example. So imagine that we have a Gradle projects, imagine you created a new project in IntelliJ, for example. To use ProGuard core, you simply need to add a dependency on the ProGuard core artifact, which is published in Maven Central. And then imagine that we have just one simple file, which we declare a main function. And what I want to do is I want to read in the class itself. So this class is going to read itself, and we're going to read some information from it. So the compile class is going to end up at this path here, build classes Kotlin main KT. And what we're going to do is we're going to read the Kotlin metadata from this class. So the first thing we need to do is to read in the whole class. So we can use some utility functions for this. This gives us a program class pool, which contains all the classes of the program. In this case, it's just a single class. After that, we need to initialize all of the cross references. So there's a tool that does this for you, this class reference initializer. This will allow us to jump between different parts of the class file. Once we've done that, we can then start looking at the Kotlin metadata. So what we can do is we can visit all of the Kotlin functions that are declared in the metadata. So this small snippet of code here will do that. It will visit all of the classes, and it will visit all of the metadata that's attached to the classes, and it will visit all of the functions that appear in the metadata, and it will print their name. So if we run this example here, it will print main because that's the only function that we've declared in the class. But if we add another function and rerun it, then it will also print foo. Okay, so then if we get back to the kind of problems that a shrinker is going to encounter, so if we do name obfuscation to make our names shorter, we're going to change the names. Okay, so in this example, if we change the Java method name foo to new foo, at this point, the metadata is now going to be out of sync because the metadata will refer to the foo function. And so this is the kind of problem that a shrinker that needs to support Kotlin needs to understand. How do we avoid the Kotlin metadata getting out of sync? So what we can do here is that we can visit all of the functions in the metadata and set their name to be equal to all of the Java methods in the metadata. So at a very basic level, this is one of the things that ProGuard would do when it's processing Kotlin applications. And actually, there is a utility function, a utility class, which can do this for you for all of the Java methods and Kotlin functions in an app. Once we've renamed the Kotlin metadata, once we've made it in sync again, we can write the metadata back to the Java annotation that's attached to the class. So this small snippet here with the Kotlin metadata writer, it will write it to the annotation. And once we've written the Kotlin metadata to the annotation, then we can write the class out again using a data output stream and a program class writer. We can write the class file. We can overwrite the class file that exists already. And so then if we open this class file in IntelliJ, then the decompiler will show us the new method, the new function name, because we've updated the Kotlin metadata. Okay, so I've showed you a very simple example of how you could use ProGuard core to modify Kotlin metadata. And the reason there was to show you basic steps of how ProGuard itself would modify Kotlin metadata when processing your application. And as I said before, it's not specific to ProGuard. any app, any shrinker that wants to then process Kotlin apps these days needs to be able to process the Kotlin metadata. If you're interested in finding out what metadata is in your application, you can use the Kotlin metadata printer that we have as an open source project. It will basically show you all of the metadata that's in your application for Java files or APKs. This is also integrated into the ProGuard playground, so you can upload your APK there, and it will show you all of the embedded Kotlin metadata. If you want to go a bit more deeper and try to write tools yourself to look at the metadata or to modify the metadata, you can look at the ProGuard core manual to learn more. And as I said, the metadata supporting ProGuard core is actually powered by the Kotlin X metadata JVM library, which is written by JetBrains. I'm also on Twitter, so if you have any questions at any later point in time, feel free to send me a message there. And thank you for listening.
Thanks so much for that, James. That was really cool to learn more about how code shrinking works on Kotlin. I didn't really know any of that. So it looks like we don't have any questions in the chat right now, but if anyone has one, feel free to drop it there. I did have one question myself, though. I was curious if any of this changes in depending on like using a Kotlin multi-platform project, or is there any special cases in that realm where things might be a bit different?
So here I'm focusing just on the JVM part here. So just the compilation to JVM or the compilation to Java class files, and then the conversion to DEX for Android. And that's basically because that's what I work on daily. So I don't know too much about how, for example, the metadata is used in the other targets.
Sure. Cool. Cool. Well, looks like we don't have any other questions coming through in the chat. So yeah, I just want to thank you again for the wonderful talk.
Thank you. Thank you.